Swayam Prabha. Digital India. Educated India.
So, what we are doing, we are actually discussing the steps for significance testing. So, first objective is the calculation of t values using appropriate formula that we have already discussed, and next was that the second objective to get some estimation, which is called as the confidence interval, where we can only estimate the population range, nature of the population. So, what will be its standard deviation of the population or mean of the population without pinpointing the exact value. Okay, so that will be that is total very helpful in understanding the nature of the population. And to do this, to get all these objectives and to achieve our target, so we have to follow certain procedure. So, and using certain tools. So, the tools which we use is, first tool is, it's called t-test. So, t-test basically it's used for, just as we have discussed, t-test is used just to know the whether this difference is significant or not. This may be for mean and also for the standard deviation. We can get this type of normal distribution for standard deviation also. Okay, so the difference between mean and the variability. So this in practical application, this t-test is always actually used. Suppose our customer, their requirement is that we need a particular yarn of count, say 50 NE, 50 count yarn, and with standard deviation 1.5 NE. That is the requirement of the customer. So, we have mentioned that we cannot give the exact value. So, by sample analysis we can predict that whether this difference is significant or not. That is the mean, t-test for mean, but the variability is also important. And to know that, we can do t-test for the variability. Now, how variability is important, let us discuss with one example, simple example. Suppose we have a target strength is x bar. This is our target strength. Okay, and one product, one lot, say lot A, when we are testing the lot A, we have got the individual data, these are the individual data, and we have got the mean of, this is the mean, okay, which is more than x bar a. So x bar a is more than our required one. Another sample which we have got, we are getting is shown by green color. Green color, green dots, and here we are getting x bar b, which is little bit less than x bar. Now, when we test the significance test, so x bar a versus x bar and x bar b versus x bar, in both the cases the difference is not significant, not significant. So both the samples are actually, it's perfectly okay. Although sample B is having little bit lower value, mean value, this is the lower mean value than the targeted, but as it is not significant, mean is not significantly different, so we accept, and we also accept x bar a, sample A, because it's also not significantly different. We have given strength is a value, but it may be some anything else, a thickness. Why I am telling thickness instead of strength, always means that higher strength is better, but thickness, higher thickness or lower thickness, or both are actually not required. So here A, as far as thickness is concerned, sample A, it's not, it's a better quality because thickness is different, but we are accepting because it's within the acceptable limit, within acceptable limit. Now thing is that which one should we accept? Even if it is for strength also, although it's high, which one should we accept? Both are acceptable. Now comes, we have to check the variability, significance of variability. There also we have to do, we have to calculate the standard deviation, of A, standard deviation of A we calculate, and then standard deviation of B, and then accordingly we have to test the significance similar to that of strength, mean, and then from the distribution we can see clearly that sample B has got less variability than sample A, and if we take the strength value, even if it is a more, mean is more, the breakage will occur at the weakest point. So more breakage will occur for sample A. So it is not acceptable although the mean is high. So the significance test, it's important both for mean as well as for variability. So we test the significance test using the t-test. T-test can be used for both variability of mean as well as significance of mean as well as the significance of the variability. And the standard formula is that for mean, it's a nominal mean by sample mean, it comes within the mod sign, because ultimately t value is always in a positive value, and nominal mean and sample mean can be more than or less than the nominal mean, and nominal mean minus sample mean divided by standard error. So we can calculate the t value and then we compare with the table t value. So this is the t test. Another test tool we use, which is called F test. F test is used only for the significance test of variability. Like t test we can use both for variability and mean. F test is used only for difference between the variability, and F test is relatively simpler than the t test. T test needs some calculation, but F test is one step calculation is there. What is F test? F test is called, it's a ratio of variance, it's a variance ratio. Variance ratio means you have, say you want to know the variability difference, say one sample has got standard deviation 1, another has got standard deviation 2, sample 1 and sample 2. Now first we have to convert this standard deviation to variance. Variance is, as we have discussed, it's square of standard deviation, and F is calculated, it's a ratio of variance. So here the variance will be V1 will be standard deviation 1 square, V2 will be a standard deviation 2 square. Now the F value can be V1 by V2 or V2 by V1. It's which one will be in numerator and which one will be denominator, that depends on the value of V1 or V2. So one thing is that selection of numerator and denominator depends on the condition that f should be always more than 1. So larger variance is always comes into the numerator. So larger variance is coming into numerator. So variance with which is expected to be greater and variance expected to be smaller is that one. So if V1 is more than V2, it will be V1 by V2. So one should remember the F is the ratio of variance, not the ratio of standard deviation, and larger variance will be at the numerator and smaller variance will be at the denominator. That is one step. And then after getting this F value, we should refer to the variance table, sorry, F table, this variance ratio table. So, and this calculated F value is compared with the standard table value. Now, this is the standard table value. This table values are given, are available for different significance level. So 1% significance level, 5% significance level. So 5% means that we have discussed 95% confidence level and 99% confidence level. Now, how to check this F table? And this is gamma 1 and gamma 2. X horizontal data are showing the degree of freedom of numerator value, and vertical values are that is gamma 1 is the degree of freedom of the numerator and gamma 2 is the degree, and degree of freedom we know it's n minus 1, and our condition here is that f should always be more than 1, f cannot be equal to 1. Why, in which case f becomes 1? F becomes 1 will be in only that case where there is no variability. Two sample, say standard deviation 1 equal to standard deviation 2. Only in that case the f will be equal to 1. And when there is no variation, we don't have to test the variability. We don't need to test the variability. So f should always be more than 1. That is one condition. And also you can see for large sample, we have discussed for our purpose, large sample degree of freedom is infinite, large sample. Now suppose our standard deviation of numerator, say we are using the sample of say 25 readings, and for the denominator SD2 we are calculating these things, n equal to 25, n1, n2 equal to say 20 readings we have taken. Now, and if we have got SD1 square by SD2 square. So SD1 is more than SD2. SD1 we have got. So this F value we have to compare with the table value. Now let us see. So SD1 is the numerator value. Numerator value is N1 is 25. So gamma will be 1 will be 24. 24 is the degree of freedom of numerator, which goes in this direction, horizontal direction. So 24 we have to check for this value, and for 99% level, 1% significance level, it's a this value. This column we have to take. We have set the column. Now row we have to set. Which row? SD2. N equal N2 is 20. That means 2 19. 19. So this is 19. So what we have to do? We are going up to this, and here 2.11. 2.11 is the value as per the table, and here it's coming, and 2.42 something. So we can do it. And our calculated T value, calculated F value, if calculated F value using this formula, if it is more than 2.11, then we will call it as it's a significant at 95% level. Okay. So this is the F value interpretation. Now suppose here 24 reading we are taking with the for numerator value, and what we are doing, we are comparing with the some nominal value. SD2 is the nominal value, targeted value. Targeted value always we have discussed, targeted value is always the degree of freedom will be infinite. Degree of freedom is infinite. And here it was in 1 was 25, so 1 will be 24, and targeted value was gamma 2 was infinite. So in that case we will compare with the 1.52 or 1.29. With this targeted value we are doing. Till this time it was okay. Now what we are doing, instead of value 25, what we are doing, we are taking large sample, say 50. So in our case, the value 50, it's a large sample. with our assumption it's a infinite. This is the target value and we are doing with the large sample. So what will happen? Here it's a infinite and here also it's infinite. If we see in this level, for both the levels 5% and 1% level, the F value becomes 1. F is 1. So as per our definition, F cannot be 1. So this is, that means if the test cannot be applied when we are trying to compare with the two large sample or one large sample with the targeted value, nominal value. So that's the limitation of F test. Next tool is that chi-square. So this method is to be used when no prior knowledge of the distribution is there. We don't have any prior knowledge, only no distribution is known. In earlier case, we need to know the distribution, that is F test, we need the standard deviation, how the data are varying. For T test also we need standard deviation. So data variability is, just a data distribution knowledge is there. But here we don't have any data. We have only the targeted value and achieved value. So whatever observed value, the achieved value, and this is targeted value. That's one. This two is only known, and from there we can use this formula, and there is a chi-square standard table is there, and from there we can compare with that, with the standard table, and we can get some idea whether this observed value is actually significantly different or not. Now we will do some different numerical. So first is that related to significance test. Now first is that significance test for single mean with small sample. What does it mean? You have one targeted value, your nominal value, and you have got one mean, and we want to test the difference value, and this mean is obtained by using small number of samples. Okay. So this number is 28, that is less than 30, small number. These bobbins are tested for a count, and the mean count found to be 42. 42 is our reading which we have got, okay, sample mean, and the standard deviation of the sample is 50. This, after testing 28 bobbins, we are getting the standard deviation of the sample, and our targeted value, our what we wanted to achieve, 40 NE. 40 NE is our given target, but what we are producing we are producing 42 count. It's a finer count. So this is a 40 count. 40 NE is our target, and we are producing 42 NE. 42 NE. So there is a difference, variation. Now we have to calculate the judge whether this difference 42 minus 40, this 2 NE difference, whether this is significantly different or not. As we have discussed, so we have to somehow calculate the T value, and this T value has to be compared with the standard table for the degree of freedom 28 minus 1, that is 27 degree of freedom we have to test. So number of samples 28, sample mean we have got 42, and the standard deviation, that is there is a distribution is there, we know the distribution. In chi-square we will not be able to know this distribution, okay. And nominal count is given. In chi-square, what is the formula? It's a observed, as we can go, this is the chi-square is observed minus expected square by expected. So here if you want to square, observed means in our at present observed is 42, expected is 40 by expected 40. So if we calculate this value, okay, and then compare with the standard table, from there we can get rough estimation, but we will not be able to do further calculation. But t-test gives us much more information. So nominal count is there. So this difference is 2 count difference is there. So first step for this significance analysis is that first you have to calculate the standard error of the mean. Standard error of mean, because why is it standard error of mean? Because we want to know the difference between the mean. If we want to, our intention was to calculate the standard error of standard deviation, then suppose the nominal standard deviation is say 5.5, nominal standard deviation is 5, that we will discuss. Nominal standard deviation is 5 and count is, so first let us solve this problem. First we are calculating standard error of mean. So standard deviation by under root n. So here you can see our initially this 5 is not given, 5 is not given. So as with the absence of any nominal or population standard deviation, so we are assuming we are taking 5.2 as a our assumption, it is close to nominal population. So in absence of any nominal or targeted or population standard deviation, we consider that sample standard deviation is equal to population standard deviation. So 5.2 under root 28, it comes out to be 0.982. Now this numerical, if in this numerical, if the numerical we can change, is the example, if we change, if the nominal count is 40s and the nominal standard deviation is 5.0, the yarn is too fine or not. In that case, if the problem is such that where targeted nominal value is known, in that case the standard of error would be 5.0 divided by under root 28. The value comes out to be 94. That much adjustment will be there. But in absence of the value, this value, we are assuming it. So standard error we have calculated, and then t value, as we know, nominal mean by sample minus sample mean by standard deviation, standard of error, it is 0.037. 0.037 is the t value calculated, and then this t value with the 27. So for the table value, we have to refer to the t value with the degree of freedom 27. So next step is we have to refer to the t table for degree of freedom of 27, and then we have to compare the table t value with the calculated t value. So calculated obtained t value is this, and then we are comparing this table to calculated t value with the table t value. Let us see the table t value. For 27 degree of freedom, this at 95% level, it becomes 2.052, and in 99% level it is 2.771. So 2.052, and what we have achieved, we have our calculation, it's being 2.03. So 2.037 is less than 2.052. That means the difference which we are getting, it's not significant at 95% level, and at 99% level we have seen it's a 2.771. So it will not be, it is also, it will not, definitely it will not be significant again. So our conclusion is that as this calculated t value is less than the table t value, so bobbins are not too fine, because the difference between the sample mean and nominal mean is not significant at 5% level, And the thing is, when it is not 5% level, automatically it will not be significant at 99% level. So the real difference is doesn't exist. So this means that 42 count, you can, when although you are producing little bit finer, but you don't have to readjust your machine count, you can keep it continuing. Now coming to the discussion, where what you are trying to discuss, the problem of variability. Now our target variability is say 5. Now we have to judge whether this variability is, we are producing really a higher variable product or not. So here standard error of mean was there. Now what we are doing, standard error of standard deviation of the population. So what will be the standard deviation of population divided by under root 2 multiplied by n. So standard deviation of population is available, so we use 5 here, under root 2 into 28, under 56, 5 divided by under root 56, this will be 0.66. This is the standard error. Now we have to calculate the t value. So t value here, nominal standard deviation, sample standard deviation divided by 0.66, standard error divided by, this is 0.66. So nominal, what was the nominal value? Nominal was a 5.2. So 0.2 divided by 0.66, value will be 0.30 something. So we can see here, again we have to compare with the table value, same table value 2.77 and 2.05, and we will see that this difference it's not significant. So we can do both for standard deviation and for the mean. Now again the similar numerical, single mean with a small sample. Why are we calling it a single mean? Because we have, by testing, we have got only single mean, and we are comparing with the nominal value, targeted value. Similar numerical, 26 ring bobbins are there, are tested. The mean is found to be 61.6. The standard deviation of the sample is 4.4. if the nominal count is 60, is the yarn too fine? So what we are producing yarn targeting 60 count, we are producing 61.6. So similar problem will be there. So here again, as the population standard deviation is not there, so we will be using the sample standard deviation in our calculation. Okay, so standard deviation is 4.4, sample mean is given, number of sample is given, nominal count is 60. So step 1, the standard deviation by under root n. So 4.4 is the standard deviation of the sample, as in absence of population sample standard deviation, we are using this standard deviation divided by number of readings 26, we are getting the standard error of mean 8.6. Then t value 1.86 is the t value we have got, and the degree of freedom is 25 degree of freedom, and we are getting the 95 and 99% level. So for 25 degree of freedom, this is becoming 2.06 at 95 and 2.788 99% level. So 2.06 is more than 1.96 which we have got, so it's not significant again. So not significant at that level. So both 99 and 95% level, it's not significant. We don't have to take any action.